Okay, so for 1995 E2, question A is what is the dielectric constant of the plastic? And the plastic we can see in the picture is in between this parallel plate capacitor. And so we know that capacitance is area of a plate times epsilon naught times dielectric constant, all divided by d, the distance between the plates. So we rearrange that for K, get CD over A epsilon naught. Then we just plug in our values. So capacitance is given 5 times 10 to the negative eighth farads. Our distance between the plates is 1 millimeter, which is 1 times 10 to the negative third meters. The area of a plate is 1 square meter. And epsilon naught is equal to 8.85 times 10 to the negative 12th coulomb squared per meter. Let me just check that real quick. I have it up here. Oh, sorry. Coulomb squared per Newton. And if we plug that into our calculator, 5e negative 8 times 1e negative third divided by 1 divided by 8.85 e negative 12, we get our dielectric constant is 5.65. And so it would be unitless. So I'll clear the screen and I'll just keep that up here in case we need it again. Question 2 has multiple parts. First is, what is the initial charging current when the switch is closed? So we know Ohm's law, V equals IR. Rearrange, we get V over R is equal to our current. And then we can just plug in the voltage is going to be 30 volts from the battery. And we know the resistance is going to be this 2 times 10 to the negative 6 ohms from that resistor. And we get the initial charging current, because it will start to decrease. It's 30 divided by 2 e negative 6. Oh, no, sorry, positive 6. And we get 1.5 times 10 to the negative 5th amps. I'm going to skip part 2 because that's going to be covered by a different group. Part 3 for B is determine the magnitude and sign of the final charge on the bottom of the plate when the capacitor is fully charged. So we know capacitance is charge over voltage. So charge equals capacitance times voltage. The voltage on the capacitor is going to be same as the battery. So we just plug in 5 times 10 to the negative eighth farads times 30 volts. And so our charge, the magnitude of the charge is going to be 1.5 times 10 to the negative 6 coulombs. And to find the charge, we're going to see bottom plate is hooked up to the negative terminal of the battery, so the sign is negative. And for part 4 of B, how much electrical energy is stored in the fully charged capacitor. So one equation is the energy in a capacitor is, when fully charged, is 1/2 CV squared. And again, voltage of the capacitor is the same as the battery for this circuit. So we just plug in our values. "30 volts squared." And we'll get that the energy stored is equal to 2.25 times 10 to the negative 5th joules. Then I gotta clear my screen again. I'll keep my dielectric constant up here. And then for part C, what is the new voltage across the capacitor when the plastic sheet is removed? The capacitor was disconnected and fully charged, and the metal plates stay at the same gap. So we know that our new capacitance is going to be lower, and it's going to be the original capacitance divided by our dielectric constant. So the new capacitance is going to be the old one divided by our dielectric constant, and that will equal 8.85 times 10 to the negative 9th coulombs. And then we use our equation C equals Q over V. V new, C new. And so we know that V new equals Q over our new capacitance. Now Q stays the same because the capacitor is fully charged and it doesn't discharge to anything. So we just plug in our values. Okay, so our charge is going to be 1.5 times 10 to the negative 6th coulombs divided by our new capacitance, 8.85 times 10 to negative 5. Sorry, this should be an F for farads. And so our new voltage when the plastic dielectric is removed is going to be 169 volts. And for D, if there is now more energy stored in a capacitor, where did it come from? If there is now less energy, what happened to it? So let's calculate what the energy is. So we're going to use the 1/2 CV squared equation. So 1/2 new capacitance and new voltage squared. And we'll get that our energy stored in the capacitor now is going to be 1.26 times 10 to the negative 4th. And so our energy stored before, so I'll put this final. Again, I'll write in our initial stored energy was 2.25 times 10 to the negative 5th. And so we gained energy, and that gained energy was due to the person having to put work into the system in order to remove the dielectric. So that addition of work is what increased the energy of the capacitor after removing the dielectric. And that is everything for 1995 E2.